Hi everyone, welcome back. In this video, you are going to learn how you can use Venn diagrams to determine the validity of an argument. You might be surprised that we are covering, a logical reasoning in this video. And what about Venn diagram? Yeah, if you don't forget, you will notice that in the last video, I explained that there are relationships between what? Between set and logical reasoning. Indeed, the conjunction in set, the conjunction in logical reasoning, the operator conjunction, so it's the same thing as that of intersection. Disjunction is more or less, union of a set. I hope you understand now. So before I explain how you can use Venn diagram to determine the validity of an argument, let me state again that the structure of algebra sets, that is what you use for sets, and that of proposition look alike, as we can see. And that's why in the last video as well, when we were proving or when we were showing some of the properties, of proposition, so the commutativity, the associativity, the distributive, and what? And De Morgan's property. You will see all these properties are also satisfied for the case of set as well. So let me now give you the associated terms so that you can see the relationship between two of them clearly before I now move to how you can use Venn diagram to what? To determine the validity of an argument. Okay, now let's say if I have set, let me have a table for set, then another table for propositions. Don't forget, set is the collection of well-defined objects. Why what? Why proposition is a statement that can either be true and what? And false, or false, but not both. So that's one of the beauty we have in mathematics. So, okay, now the first one I'm going to make you aware is that when you say set, set is denoted by uppercase letter. Maybe you have set A, set B, set C, and so on. So likewise, you can have proposition too. Proposition is also denoted by uppercase letter. Maybe you have proposition A, proposition B, that is statement. I hope you understand now. And union, like I've explained, when you have union of a set, which is denoted by this, like, then it's the same thing as your disjunction. Disjunction, so which is more or less like two. So and don't forget for union, that is elements in A or B or H or both, and that's why we use or for disjunction too. So intersection, what is intersection? We use a what? A cap like. So what is related to intersection in proportion, in proposition? That is what? Conjunction. Conjunction or and. And that's why when you want to find the intersection of two sets, you look for element in A and B. That is the common element in both what? In both sets. So likewise, the complement, if you don't forget what is complement, that is elements in a universal set that are not in what? That are not in a particular set A. So the complement which is denoted by this is the same thing as implication, implies your if then. Yeah, please take note of them because we are going to be using them. So, but when you say a subset, is a subset of, for is a subset of, you are going to use something of this nature. So, sorry, I made a mistake. I made a mistake. Your complement, it is not as it's not the same thing as imply. It's the same thing as negation. It's like we are negating when you say complement. That is what you have in the universal set that are not in the set. Likewise, what is related to it is your negation. And don't forget, negation of a truth value which is true is going to be false. I hope you understand that. That's negation. So, but when you are talking of is a subset of, can you say it? Which one is closer to it? That is what? Eh? That is implication, implies. And that's why if something, then something, then it means it's more like a subset of, that thing. And if like say if P then Q, it means P is more like a subset of Q, and Q is a superset. So implies, or you say your implication, your if then. Likewise, your equals. When do we say two sets are equals? So when, one set is a subset of the other, and the other is a subset of the first set. So, and this equality set, equal set is not the same thing as equality. So the equal set here is the same thing as equivalent in the case of proposition, equivalent, or your if and only if. So if that is cleared, don't forget also that you can also draw your Venn diagram. You know, like I used to say in your what? In your set is denoted by what? By a circle. Your set is denoted by a circle. Then while your what? While your universe set is denoted by a square, or you say a rectangle. When I have something of this nature, for example, this is my universe set. I hope you understand now. Then if you have a set here, maybe I have a set A. I hope you understand now. Then I still also have another set. You know, by me drawing it inside each other, okay, don't forget this is your inverse set. If this is your set A and this is your set B, we can say now that our B is a subset of A. You can use the same logic. This is for set. You can use the same logic here as well. Let's say I have, so your proposition also will be denoted by what? So will be denoted by, a particular proposition will be denoted by a circle too. So then you can have your universal proposition, that is uh, the, the proposition that contain all the possible, proposition under consideration. So let's say I have universal set like this. So if you have a circle, I hope you understand now, and you also have another smaller circle. So recall, what do we, your circle now, if this is a proposition P and this is another proposition Q, what this one is saying is Q is what? Implies P. Are you getting that now? So that's like a implication. So if that is clear, let us now move to today's business. For today's business, how do we now use Venn diagram to determine the validity? When you say something is valid, that is when you are trying to make sense of, trying to make truth of something, and you later, find it to be true, then it becomes valid. When you say something good about someone, and after some investigation you later found out that that someone is good, the person is good, then that's what, that description is valid. Likewise, when you say a proposition is valid, that is okay. Now if I say Lagos is in Nigeria, is a proposition. We can determine whether it is true or false. So if at the end of the day we are now, conclude that Lagos is in fact in Nigeria, then that proposition is valid. I hope you understand now. So like I've said, like I've informed you in the first video, that when we talk about logic, it's just a branch of mathematics that deals with what? With reasoning. I want to tell you the meaning of argument so that you understand it correctly. So when it's now deal with reasoning, so and in mathematics we have like two type of reasoning. You understand now? So now the first one is inductive reasoning. When you get to, higher mathematics, you'll be doing something like a mathematical induction. I hope you understand now. So you'll be doing like mathematical induction. In essence, when you want to use your mathematical induction, that is, you want to use a kind of inductive reasoning, you are going to base your conclusion on observations. Okay, now maybe you've observed something, when you get to mathematical induction, it means when you observe, perhaps when you test for, maybe when you want to test like a formula is true for all the integers, when you test for n is equal to 0, n is equal to 1, n is equal to true, then base your observation on your observation, you can now make what? You can now make a conclusion. That's what? That's inductive reasoning. So that is when you base your what? Your conclusion on observation. Another type of reasoning we have, so which we use most, is what? Your deductive. Deductive is like it is formulated from deduction, to deduce. You understand now? So to deduce something. When we have now deductive reasoning, That is the process of showing that certain statements are accepted as true. I hope you understand now. So the process of showing that a certain statement are accepted as true. So in essence, when you are talking of deduction or deductive reasoning, so all the possibilities you are considering, it means you've exhausted them. I hope you understand now. And hence you can come, and that's why we use hence in mathematics. You will come across something like that, and therefore you can come to what? A generalized conclusion. Okay? So you can come along with what? With a generalized conclusion. I hope you understand now. So I hope you understand now. So in essence, we know that we have two type of reasoning. Number one, the inductive reasoning. So that is a kind of reason where your conclusion is just based on what? On your observation. What do I call your deductive reasoning? That is you deduce. I hope you understand now. So you deduce, which is the process of showing that certain, statements are accepted as true. I hope you understand now. So if I say, for example, now A plus B, or let me say A star B is equal to AB. We can deduce from here that when I have 2 star 3 is same thing as 2 times 3. I hope you understand now. So you can see that, we deduce, that is, we find like a process of showing that these certain statements are accepted as being true. I hope you understand now. So when we now say argument, then your valid argument may be referred to as deductive argument. I hope you understand now. Remember I said we have inductive and deductive one. But a kind of deductive reasoning is same thing as valid. When we say something as valid, then it means at the end of the day, you are able to what? To justify that this something is either true or what? Or it is false. I hope you understand that, because our deductive reasoning is based on what? Conclusion reached from valid argument. So it is based on conclusion reached on valid argument. Inductive is what? Based on what? Our mere observation. So in essence, in deductive reasonings, you must start with an assumptions. Okay, now Lagos is in Nigeria. It's like an assumption. Then you have to test, or maybe, oh, Mariam is a good guy. It is an assumption. So you start that. Then if you want to deduce, or before you can get a valid argument from that, then you have to test Mariam. Okay, now on Mariam, can she give you money? Is she kind to you? I hope you understand. Now, if you are able to deduce all the properties of goodness, perhaps you find it in her, then you can conclude adequately that what Mariam is very kind. So, like I've said, so you have to start with assumptions. You start with assumption, and this assumption is on textbook. We call it what? Hypothesis. So you can call it hypothesis, or you call it premises. That is, you premise it on something. So if you premise it, like Mariam is good, that's what? That's an argument. Then you can have a conclusion based on what? Based on those your assumption. So what I'm trying to say in essence is that when you have a mathematical result, so we discover mathematical result or mathematical proof from inductive reasoning, induction. Like I've said, you come across mathematical induction when you get to higher level. But when you want to what? When you want to prove them, I hope you understand now. So when you want, perhaps when you come across them, so you use your result, you use like induction, like that is a formula, for example now. But when you want to prove them, what you are going to use is what? Is your deductive reasoning, that is your deduction. So that is your deduction. And don't forget, like I've said, your argument may be described as a set of statements. So, or proposition, statement is also a proposition. So so when you describe it as a set of proposition, call the premises, and your premises can also be what? An hypothesis, which leads to a what? Which leads to a conclusion. Then we call it an argument. Let me write it down so that perhaps you might want to jot something. So argument So that is a set of statements, a set of statements or propositions, so which are called what? Premises, or you can call them an hypothesis. So which leads to what? To a valid conclusion, which leads to a conclusion, which leads to a conclusion. So let's say, for example, I want to link it together now. Please get it clearly because this used to confuse many students. Let's say I have P, Q, R up to maybe X or to Z now. If they represent my represent premises or what? Or hypothesis, anyhow. So, or assumption, anyhow you call it. So if they represent your premises now, and your C, let's say C represents conclusion. If your C represents conclusions, I hope you understand now. Then when you are now talking about a valid argument, don't forget I describe a valid argument here, but I want to express it mathematically, logically. So then a valid argument is one in which all your premises are true. That is your P, Q, R are what? Are true. So when you have like a hypothesis, assumption, at the end of the day, when you now test them and you find out that your hypotheses are true, then you have what? You have a valid argument. So you have a valid argument. In other words, an argument is said to be valid if the conjunction of the compound statement, that when you have conjunction P, Q, R, before, don't forget one of the properties of conjunction is that when you are using conjunction as your connective, before you can say it is true, it means your what? The both statements must be true. Or even if there are more than two statements, they must be true. Are you getting that? Now all of them must be true. So it means the conjunction of P, Q, R so implies what? C. That is, if it gives rise to a conclusion, then this is a what? A tautology. I hope you understand. When do we say a tautology? That is when you have the truth values. I mean, all of the truth value is what? True, irrespective of the combination. Irrespective of the combination. So, and if this, I hope you understand the valid argument now. That is when the what? Eh, when the conjunction of what? Of your proposition implies a conclusion, then we have a tautology. I hope you understand now. So, so that is a valid argument. That is, if your premises, if all of them are true, if your proposition are true, then the what? The conclusion is always true as well. That's valid argument. On the other hand, we have an invalid argument. An invalid argument, as the name implies, what will be an invalid argument? So at times we call them fallacy. That is, they are not valid. Are you getting that now? So what do we call that? So if that is when you are able to show that an argument is not valid. That is, at the end of the day, when you have your P conjunction Q conjunction R, and this is not what? All of them are not true. I hope you understand now. All of them are not true. That is, it doesn't give you, or let me just say, see, it's not a what? It's not a tautology. It's not a tautology. You understand? At times, it is possible for you to have a valid argument. At times, we may have a valid argument, but a false conclusion. Do you get that now? We can have a valid argument, but what? But a false conclusion. Okay, for example, now, if I say Mariam is good, is a good guy, this what? Maybe is a valid argument, but you don't know how to prove it. Or an invalid argument, but you can have a true conclusion. So that's what we call like a wuru to the answer. But an argument is valid if the conclusion follows from what? From the hypothesis. Let me give you an example to back it up so that you know all this story I've been what? I've been saying since morning. Example, example. So use Venn diagrams to determine the validity of the following. When do we say an argument is valid? That is, if you are what? If the conjunction of all your proposition is true, then you have your conclusion to also be true. Valid argument with premises, and your premises are maybe you have P, Q, and you have conclusion C. You have conclusion C. So let me change my marker so that you get it very well. Okay, now the first one here, I have P. All bus drivers are men. That's my first proposition. My Q is what? Tunde is a bus driver. You know, we have what? We have true premises, true proposition. When they write something like this, it means what will come after it is your what? Conclusion. Therefore, Mama is a man. Think of it yourself. All bus drivers are men. That is, everybody that are bus driver are men. Then today is a bus driver. And so, if today is a bus driver, can we now conclude that Mama, Tunde, Tunde is a man? From there, is it, it is trivial that Tunde will be a man, but how do we show that? Okay, now let us show it. So, your premises are both, like I've said, are what? PQ. These are your premises. And your conclusion are those that came what? After this line. This is your conclusion. So then it means my universal set is now what? People. Don't forget that is the set that contains all the possible what? All the possible sets under consideration. So let my universal set be people. Then M represents men. If my M represents M represents men, and maybe B is what? B represents bus driver. So if B represents bus driver, you know, for example, now, since we have a universal set and we want to use what? Venn diagram, this is what you are going to have. Let me draw Venn diagram. Your universal set is denoted by what? It's denoted by square like this or rectangle. Then you have a circle like this. I hope you understand now. So if you now have a circle that represents all men, let's say I denote this circle as all men, if this is M, I hope you understand now. So, and if I have another circle, which is the first premise, the first premise say all bus driver are men. That is they are men. I hope you understand now. So then, since they say Tunde is a bus driver, if they say Tunde is a bus driver, so, or let me say, they said all bus drivers are men, then we can say B implies M, since B will be a subset of M. That is bus driver, they are subset of M. Like I've explained up, it means I can have my M here, which is another set, my B, which will be a bus driver. By this, we can say B is like a subset of M. And what is related to subset in proposition? That is implication. B is a subset of M. And if you check that one very well, Tunde is a bus driver. I hope you understand now. So Tunde is a bus driver. If I say let Y represent Tunde, so if you represent Tunde with Y, let Y represent Tunde. It means where are you going to put Tunde? You know, Tunde is what? Is a bus driver, is going to be here. And if you check it very well, I represented it with Y. So if you check it very well, Tunde now is what? Is inside set what? B, which is what? Eh? Which is bus driver. And bus driver is also a subset of M, which is what? All men. Then we can conclude adequately that what? Tunde, which represent our M, that is Y, is what? Is an element of B, which is a subset of M. Then we can say Tunde is what? Is a man. Can you see it is very simple, please? You don't need to stress yourself, it is just like that. So just think of it very well. So let me give you second example so that I stop the video. Second example, let's say I have my first premise to be no politician is poor. No politician is poor. Then my second premise, maybe Rufus is a labourer. And you have your third premise, that is all labourers are poor. I hope you understand now. So then the question says use Venn diagram to form a valid conclusion such that the above is what? Is valid. Such that the above is valid. Okay. We have our first premise, no politician is poor. Don't forget, first thing to do is to what? You have your universe set. Let universe set represent what? All people. I hope you understand now. And maybe say P represents politician. Politicians. I hope you understand now. Maybe you represent Q with what? Poor people. Represent P, Q with what? Poor people. I hope you understand now. So, or maybe you also represent L with what? You represent L with laborers. You represent L with laborers. So now, first thing to do is to draw your universal set. Your universal set, that will be in form of what? In form of square or circle. Then you have your square like this. I hope you understand now. So if you check the first one now, so the first premise, no politician is poor. No politician is poor. It means when you have a set or a proposition for poor, maybe I call this poor, or let us continue. No politician is poor, but Rufus is a labourer. And let's say I represent, I mean, let's say this one represents a labourer. Rufus is a labourer. It means, and we have that all labourers are poor. So all labourers are poor. So if this represents poor, let me say this region represents poor. If it represents poor, then I have another set now. Since we were told that what? Laborers, all laborers are poor. I hope you understand it. Then you have it inside here. Laborers represent our laborer with L. And now you can represent the first one now. That is no politician is poor. Maybe you represent this guy. Oh no, this is Q. My poor. I represent Q with poor people. Right? Okay, now if you have another one now, which represents your politician. So you know this represents your politician. And what is the last argument? So maybe we want to prove, I mean, uh, for example, now we have like a Rufus. uh So Rufus to be a laborer there. So, and Rufus, let's say let Y represent Rufus. Let me ask you, where are you going to place Rufus here? If Rufus represents Y, and don't forget from these premises, it means Rufus is a laborer. And where is our laborer? It means Rufus is going to be here. Maybe I call this place Y. I hope you understand now. So then you can conclude that Rufus is not a politician, is it? Because you can't find it in this set or in this proposition. It is only here. You can only say maybe Rufus is a laborer. Since Rufus is a laborer, he's going to be poor, but Rufus is not a politician. So, and you can see it is very clear from this diagram. So, therefore, Rufus is not a politician. I hope you understand. So that's how you are going to be doing it. Just link the idea with what we've gathered from search. So I hope you understand. Now, if you understand this video, please don't forget to like, share, and subscribe. Also, I advise you go to your past questions. I hope you understand now. So solve a related question. If you have a problem, don't forget to contact me, and I'm going to, advise you on how you are going to solve such a particular question. So if you understand this video, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.